In this video, we're going to talk about interfaces. So to begin to understand why we need interfaces, let's look at an example here that I've created. This is a demonstration of a phone. So I have a class called phone.java, and my phone has a number. I have a constructor for my phone that creates a phone with whatever number I specify. I have the ability to dial. Okay, and I can dial a phone number from my phone, and it will call it. I have the ability for my phone to ring, and it checks to see if the phone number matches my number, and if it does, it rings the phone. I have the ability to answer my phone. So there's a method for answering the phone, and there's a method for hanging up the phone. And that's great over here in my test class, my driver class. I create a new phone with the number 1, 2, 3, 4, 5, 6, 7. I can ring the phone. I answered it. I can hang up. And if I run that, you can see that happens. It rings the phone, it answers the phone, it hangs up the phone. All right. So then I decided, okay, cell phones are a thing now. So I'm going through my life here. When I was young, we just had phones that hung on the wall, or we had a phone that sat on the desk. And then cell phones came along. Cell phones work just like phones, so hey, let's just inherit from phone and we'll have all the functionality of a phone on our cell phone. But our cell phone has a couple other features as well. We have the ability to turn our phone on or to turn our phone off. Uh, and also, when our phone rings, I can override the ring method here, and so that my cell phone will actually play a ringtone instead of just ringing a bell like a house phone or a desk phone would. So over here, I created a cell phone. I can call it. It can answer. It can hang up. Let's run that to see. And when the cell phone rings, it plays a ringtone instead of playing ring ring. Okay, so that's nice. It's convenient. We're using inheritance, a great thing, right? Cell phones are a lot like phones, so we can inherit from them and add features to them and be more specific, and that works well. And then at some point along the line, somebody decides, hey, we should be able to make phone calls from our computer. So now what do? I can go in here and I can create a new class, a new Java class called computer. And then what's its super class going to be? It's going to be a phone. Just, and we start to see a problem here. Um, Computer is going to inherit from phone, but a computer might need to inherit from some other things. We can only inherit from one class. Computers are way more functionality than phones. It really doesn't fit. It really doesn't fit that a computer should inherit from the phone class. Um, so how do we get around that? How do we get around? I don't want to limit my computer to being a special kind of phone, but I want my computer to be able to use the functionality of a phone. So inheritance has some limitations, doesn't it? We want things that are phones to have some functionality, which we've already covered. We already said it here that the basic functionality of a phone should be the ability to dial, the ability to ring, the ability to answer the phone, the ability to hang up the phone. That's what a phone should be able to do. That is the functionality. So inheritance might not be the best solution for trying to add a computer to our project, because it would be way too limiting, because computers can do so much more than be phones. So we want it to be able to implement, that's a key word, implement the functionality of a computer, or excuse me, implement the functionality of a phone and still be a computer, not a specialized type of phone. So we don't want to use inheritance. Instead, we're going to use interfaces. So let me delete that out of there. I don't want this class anymore. Refactor, safely delete that class. We haven't used it. All right, so let's go down, and instead of this project, I'm going to create a new project. Actually, I already created the new project here, and we're going, but we'll come back to reference what our phone can do here at some point. So I'm going to collapse this, and here is my new project, my new project, and we have a driver class here. So let's think about a better way to implement the ability of a phone. So what I'm going to do inside my package, I'm going to say new, and I'm going to say Java interface. And I am going to call this iPhone, I-P-H-O-N-E. And I am not calling it that because of Apple. This is not an Apple iPhone. This has a capital I on it, not a lowercase I. The reason it has a capital I is because it's going to be an interface. And so very often interfaces are named, not always, but a lot of times we name interfaces starting with a capital I. So when people see it, they know it's not a class, they know it's an interface. That is not always the case, but that's what we're going to do. It's a very, very common thing to do. So now we have this thing, this public interface iPhone. Now, what are we going to do with it? Okay, so an interface is kind of like a special class. You can see there's not a whole lot different here. If I put the word class here, that would be a class. Instead, I just have the keyword interface here. What goes in an interface? Well, an interface has two things. It has constants and it has abstract methods, and that's it. The only thing you put in an interface are some constants if you need a global constant of some kind. And usually it's just abstract methods. So what are the things we said a phone should do? We said it should be able to dial, and people will need to pass in a phone number if they want to dial the phone. And that's it. This is an abstract method. Okay? We do not have to provide implementation. We do not have to put the block of code and put any code on how to dial a phone. We're saying if somebody wants to make something that implements our interface, they have to provide a method to dial a number. That's what it is. Sometimes people like to look at interfaces as a contract. This is a contract. If you want to make a phone using my phone interface, you must provide a method for whatever class you write that uses this. They must have a dial method that accepts an integer. Okay. Now, I said this is an abstract method, but I didn't put the word abstract in here. Because it's an interface, it's only allowed to have abstract methods, so you don't actually have to put the keyword abstract, but you can. If I put abstract in here, if I spell it correctly, okay, there is no difference. So you don't usually see the word abstract for the methods of an interface. It's not written in there, but you should know every method inside an interface is automatically abstract, meaning anybody that uses this interface must implement a dial method. All right, what other things did a phone need to have? It needed to have the ability to ring, and I believe that took an int for the phone number as well in our original project. That's how we did it. Phone also needs the ability to answer. And it needs the ability to hang up. a spelling mistake there. So there we go. Public void answer, public void hang up, public void ring with the option for phone number and dial. These are the abstract methods that I'm saying anybody that wants to pretend they're a phone, anybody that wants to have the functionality of the phone, any class that wants to have the functionality of being a phone must implement these methods. Now we're going to see how to use it. So let's come over here and make a new class. And this is going to be, I'm going to create a wall phone. When I was growing up, we had a phone that hung on the wall. So we'll create a wall phone. Okay. And we have the ability to specify what interfaces are going to be implemented in our wall phone. So I'm going to hit browse and I'm going to type iPhone here. And it shows me the interface that's in this package called iPhone. So I'll use that and I'll say finish. Okay, so here's our class, and our class implements iPhone. So we could have done this manually too. We could have just typed, we could have just typed iPhone implements iPhone. If we just created a regular class, we could have typed it in there manually. But you can see automatically there's an error there. It says wall phone is abstract and does not override the abstract method hang up in iPhone. That's just the first error it found. Okay, because it implements iPhone, it must include all these abstract methods. So we need to write a dial method, a ring method, an answer method, and a hang up method for wall phone. It is required of us, and this class will not compile until we implement those methods that are not there. Now, I can do something like this: implement all abstract methods. Great. Hey, look, it'll do it for us automatically. So what does it do? It creates a bunch of the methods for us. Okay. But for each one of them, it throws exceptions. Not supported yet, meaning we still have to write the code for it. So we can do that. Let's get rid of the error messages. And we'll just fill in the code that we need for each one of these. There we go. Okay, so theoretically now we've implemented these, even though we haven't written any code in here. And if I save it, you can see the error went away because now I have overridden and wrote, even though I don't have any code in there, all those methods that were defined by iPhone now exist in wall phone. So wall phone has implemented iPhone. So I can go through here and implement each of these: dial, ring, answer, and hang up. I'm going to pause and do that magically to shorten the video a little bit. All right, through the magic of editing, I put all the methods that we previously had, I implemented them here, but notice we still haven't created for wall phone constructors or anything to hold the number. So I'll need to add those. So we still need to have some fields. Private int my number for the phone number. And we probably need some constructors. Let's implement a constructor. Insert code. Do a constructor. It includes the number. All right. So we've created a wall phone that implements iPhone and everything works correctly. Now I could go through and do the same thing for cell phone, and I am going to do that as well. So let's create a new class, new Java class. We'll call it cell phone. Now, something we could do here. I want to show you something. No, let's do it this. We'll keep doing it this way. I'll go ahead and hit finish here, and I'm not going to specify the interface for my cell phone. Okay, so there's my cell phone class if I want to, and then I can just add okay, and the minute I say that it implements iPhone, it tells me must implement all the abstract methods for iPhone. So we have to go through that process again. I'm going to pause while I fill that in for you. All right, so we have a cell phone. It has a dial method. It has a ring method. It has an answer method. It has a hang up method. All right, so let's do the class that we talked about. And I'm not going to, let's just do it. We talked about, hey, a computer can act like a phone, right? So let's create a new Java class for a computer. We're going to model a computer. All right. We want our computer to do lots of computer things. We can have fields for a computer. We can model a bunch of methods. So we could, this could be a huge file if we're creating a class to model a computer, right? So it's going to do all the things that a computer should do. It'll run programs and load programs. It'll access the hard drive and do all those things that a computer should do. And that's great for the computer. Not a problem at all. But at some point, we want to try to make a phone call from our computer. So in addition to all the things that a computer does, we can also tell the computer that it extends, implements iPhone. And now we can write all the functions that are required by the iPhone class. So let's do that. iPhone requires all of these. Let's use our tool to implement all the abstract methods. And then we'll just create all these, get rid of these error messages. And we can say dialing. And we'll put the phone number that we're dialing from this computer. Okay. And for ring, doing computer stuff. Let's do it this way. Playing a song indicating somebody has called this computer at this number. Playing a song. Actually, let's not play a song on our computer. Let's show a notification. We love pop-ups, annoying things. Show a pop-up. Because that's how a computer might tell you have an incoming call. It might just pop it up on your screen for you. How about answer? We'll simulate that. answering a call on the computer. And then finally, hanging up. As long as we implement them, we're okay. Disconnecting the call from our computer. Now, obviously, we could write code that actually did this if we wanted to, but we're simulating it. Should these methods be here at the top of our class? Probably not. They should be down somewhere after all of our computer type methods. Let's put them down there. All right, so there we go. Our computer can now get the functionality of a phone without actually being a phone. So that's one of the benefits to an interface. I provide all the methods that are contracted when I implement the interface so that dissimilar objects like computers and phones can have similar functionality and it can be enforced. Now, let's go make a wall phone, a cell phone, and a computer. In our driver method. So, wall phone equals new wall phone, the number 1, 2, 3, 4, 5, 6, 7. That'll be the telephone number we're going to use for our wall phone. Okay, now our cell phone. We'll make a new cell phone. 2, 3, 4, 5, 6, 7, 8 will be its number. Okay. Now we'll make a new computer. Our computer doesn't have a number. Because we didn't set a field for that. Maybe we should. No, I think we're okay. I think we're going to go with it this way. And I may come back and add it. We'll see. Computer. Yeah, our computer doesn't have a constructor to tell what its telephone number is, but that's probably set on the computer inside some software, right? So we'll go with this. Let's run this. No error. So it created the objects, but we didn't see anything about it. Now let's create a loop. Actually, let's create a list. So I am going to create an array list. Array list of type. Now, what should my type be to be able to hold all these? Computer, cell phone, and wall phone don't inherit from the same class at all in this case. But they all implement iPhone. So I can create an array list of type iPhone. Okay. Right, I have to implement array list. And this is iPhone. And I need to give it a name. And I forgot to capitalize my L there. Lots of mistakes. All right. Phones.add. Let's add wall phone. Phones.add cell phone. and phones add, we'll add our computer. Okay, so now I have all my phones in a list, and it's an array list of type iPhone. And now I can process that list using a loop for we'll use iPhone for the type. For and here we go. For iPhone, for each phone in phones, and we're using the type iPhone for that. So I can use this type, I can use my interface as a type anytime I want. However, I can't create an object from it, but I can use it for a type for my variables as well. So I can hold all these dissimilar objects. Wall phones and computers are completely different, but since they all implement iPhone, I can use them in a list of type phone, and I can do something like phone.dial. And give it a number. I'm going to call that phone number from each one of my phones. Okay, so calling, and calling. So each one of my phones was able to call that number. And I was guaranteed that they all knew how to dial a number because they all implement iPhone, and iPhone requires them to have a dial method. I can have them all ring. Okay. Now, why didn't the other two phones ring? Because the other two phones, the wall phone and the cell phone, both had a check to see if the phone number matched their number. So let me do that again. I probably should have done that in computer as well. So I probably need some work on my computer class there. But if I call 1, 2, 3, 4, 5, 6, 7, that's my wall phone. My wall phone should ring, and my computer phone technically shouldn't, but my computer phone, or my computer, we said needed some work. So my wall phone did ring. If I call 2, 3, if I call the other phone, the cell phone, it plays a ringtone. My computer shouldn't be answering there, but it's dialing all of the phones. So benefits of an interface. We can make a list to store items. Dissimilar things can have similar functionality. So wall phones and computers both implement the same functionality of a phone. And dissimilar things can be kept in a list of those types. So we're going to go talk about some of the details in the upcoming videos, and we'll make sure that we've covered everything that you need to know from a theoretical standpoint now that we've seen an application of it.